All right, question 28. We have f of x equal to x plus 6 times x minus 4. Which of the following is an equivalent form of the function f above, in which the minimum value of f appear as a constant or coefficient? Okay, so we're looking for an equation that's equivalent to this. Okay, had to be the same thing. And then also have to show us the minimum value as a constant. So, well, what does that mean? Okay, so so that means from the equation, we have to be able to tell what is the minimum value of the function. Okay, so the minimum appear as a constant, so it should be a number in the end by itself, right? So it's a constant, or a coefficient could be a number in front. Okay, but again, that number we have to be able to tell what the minimum value is. Okay, so let's think about this. Okay, what are they looking for is the minimum value of the function. This is a quadratic equation. Okay, so the minimum value for a quadratic equation is always going to be where the vertex is. Okay, so we're looking for the maximum or the minimum. Remember, quadratic equation, they're like a parabola, right? It's like a U shape. If it open upward, we should have the vertex is the lowest point, so that's the minimum. If the parabola open downward, then the vertex is the highest point, so that will be the maximum. Okay, so pretty much this question, we're looking for the vertex. Okay, so it should be in the vertex form so that we should be able to tell what is the vertex. Right, so the vertex form will be like this. So it'll be y equal to a times x minus h squared plus k. Right, where h comma k, that'll be the vertex of the parabola. So pretty much we have to have a number in the end, right, plus k. So the k value is actually the minimum or the maximum. All right, so look at the answer choices. And we know they're looking for the vertex as a constant. It's not going to be A or B. Okay, so A or B is not in the correct form. So we don't have the vertex as a constant. Okay, so B is in the standard form. So for B, this tells us about the y-intercept. So the -24 is going to be the y-intercept of the graph, right? If they said which one give us a y-intercept as a constant, then that would be B. Okay, but for this one, we're looking for a vertex. So the one that's in the correct form should be either C or D. Okay, but then which one is correct? Okay, so we have to be able to verify this. Okay, so we could solve for the vertex here, right? So we can either multiply these out and try to confirm, right, or try to verify it, or we can actually solve for the vertex. So if we're gonna solve for a vertex, what I have to do is recognize right now the equation is in the factor form. Okay, so we can go ahead and say we have set each factor equal to 0 and solve for x. We get x equal to -6 and x here equal to 4. So these will be like the zeros or the x-intercept. Okay, so the vertex is always going to be right in the middle. It's going to be on the axis of symmetry. So it should be the average of these two numbers. Okay, so we can do -6 plus 4, and then we can divide it by 2. We should get -2/2, which is -1. So this is going to be the x value of the vertex. Okay, and then to solve for the y value of the vertex, we can plug it into the equation, which will be, so we -1 plus 6 times -1 minus 4. This should be 5 times -5, and we get -25. Okay, so the y value of the vertex should be -25. And that's actually where the minimum is. Okay, so the one that have the -25 in the end, that should be our answer, which is letter D. Okay, and we think about the vertex -1 comma -25. So we plug it in, right? H is -1, so when you plug it in, it will be x minus h, so it'll be flipped. It will be x plus 1 squared, and then the k value is -25. Okay, so you can also multiply this out, right? If you can multiply this out, do FOIL and common like term, it should be equivalent to this here if you multiply. Okay, so that's another way to verify this. So for question 28, the answer should be D here.